Good morning. Yeah, I'm going to have to stand here because I have a Mac, so I have to manipulate my computer, but I also like to walk around. I'd like to thank you very much for inviting me to come and speak at this conference. We have several conferences in Norway with teachers as well. One of them gets about 2,500 teachers every year, and they're also presenting a lot of the work that they're doing as well because it's really inspiring to see what they're doing. I just thought I'd tell one slide about the center that I'm director for. It's a center that was set up by the Ministry of Education in 2016, and they wanted a national center for research and competence around this new field of learning analytics. I knew that learning analytics is really just could be a phase, we don't know. So we made it a little bit broader, so it's a Center for the Science of Learning and Technology. And we look at learning analytics, AI in education, creativity, learning, technology, innovation, but we do all facets of human learning. So we have projects from schools to workplace, formal, informal. We're not restricted. And it's a multidisciplinary center. That was one of the requirements of the government. So we have people from computer science and psychology and education, and we try to work together. And we should also, in addition to carrying out research, also inform educational practice and policy. And at the moment, we're one professor hiring one more, 3 researchers, 1 postdoc, and 6 PhD students. We have our own systems developer since last September. It's fantastic, finally, and 6 master students. Okay, so today I thought I'd just give an introduction to what the field of learning analytics is, very briefly, and then I selected 3 projects that we have that are related to schools, and then just reflect at the end on what we've learned in the last number of years that we've done. So the most common definition of learning analytics comes from a conference in 2011, and it says that learning analytics is the measurement, collection, analysis, and reporting of data about learners and their context. So it's not just about the person, but also the environment and the context around it. And we want to use that data for purposes of understanding and optimizing learning and the environments in which it occurs. We could really just say it's about data and improving learning for students. One of my PhD students did a word cloud from all the Learning Analytics Conference abstracts, and nicely we see that learning is the most common word, of course, and this was taking out the phrase learning analytics as well, but it was about learning, it's about data, it's about students, it's about analysis, it's about modeling, tracing, assessment, intelligent, and I'll come back to that in a moment. When we look at the field, just a little bit history, it's very short. So the society was formed in 2011. We had the first conference in 2011. They started a series of summer schools in 2013. So every year there's a 1-week summer school somewhere. And because they're usually held in the US, they started having local summer schools as well. So you can go for a week and you can sit and play with learning analytics approaches and techniques and things like that. It's great fun. A field becomes, I don't know if you can say mature, but becomes a serious field when you get journal. So the journal was started in 2014. And we in Norway had the first Nordic. We decided to go Nordic instead of just national. We had our first summer school in 2017, and we've had one every year since. And also in 2017, the Society published a set of open handbooks. You can go onto the Society website and download some very fundamental papers that explain the field a little bit. So those are all free. This year's Learning Analytics Conference is going to be in Europe for the first time in Frankfurt at the end of March. So if people are interested in going, and they actually have one of the workshops on the pre-conference days is about learning analytics in schools. So if there's somebody in particular interested in that, it's a 1-day workshop around that. When we look at learning analytics as a research field, for me, I interpret it as drawing on a number of already existing fields. It's nothing new to me, having been in this been in technology enhanced learning for many, many years. But it's maybe pulling things together. So if we look at technology enhanced learning, computer supported collaborative learning, they've always been analyzing networks, for example, mobile learning, online learning, artificial intelligence in education, as we've heard from Donald. For me, it's very related to this particular field, in particular the intelligent tutoring systems, the educational data mining, which has been a field around also from the 80s. So some of these fields are from the 70s and 80s. We've always been interested in, when we had technology, and doing something with the data because it was easier to get the data. From the learning sciences, we have psychology and education, some people even using things from neuroscience, computer science. And then when we look at the big data and business analytics, so you can find aspects of all these fields drawing together. And they call the field learning analytics and knowledge. Okay, so if you read about LAC, that's this field. Okay, so what is this really about? I like to use this figure, which is a visualizations of the International Standards Organization's representation of learning analytics. So it starts with some kind of learning activity. Then you have some kind of data collection. You have to store the data and process it, analyze it, visualize it. And something Donald also said was really important. We have to have some kind of feedback, make the information actionable, because if we don't have the feedback, we're not closing the cycle. Okay, and I like to say that each one of these boxes is a research area in itself, a subfield. So for example, how do we design good learning activities? It could be your chatbots, or it could be some robot project or whatever. So like, how do we design a really good learning activity? And then how do we collect data from that? And that is one thing that I'll come back to at the end, because people say that data is everywhere, and I will say it's not. And it's not always the data that we want that we get access to. So thinking about the data that we really want is important. Storing and processing the data, how do we do that? Do we make learner record stores? It's more architecture-oriented things. Ask anyone who works with big data, 85% of the job is wrangling with the data, getting it into a format that's usable and that we can work with. Aspects of interoperability as well. What if you have two sets of data and you want to use them together? That's a really big challenge. I have a PhD student working in that area. So what does time mean? Time could be measured in seconds in one data set and minutes in another, but it could also be a time span in one and a single point in another. So all these things, you need some way to bring these kinds of things together, and that has to do about this handling of the data. And then we've got analysis. In learning analytics, we have everything from regression analysis to neural nets and machine learning. So how do we choose a good algorithm? Often on a learning analytics data set, you have to try 6 or 7 different analytics techniques in order to find something reasonable about it. It's not straightforward. Then we have visualizations, and I'll come back to this in the end. How do we visualize data so that it's understandable and that it then can be actionable, and how do we act on the data we collect? Another way to think about it is from the data itself. So we can collect microdata. We can collect data that's happening in the classroom or on a particular tool, and we can move that data up from the micro individual user action to the institution actions to national actions. Think about PISA data or things like that. It does start down with the individual student, and it's propagated up to say something about our countries. So should we be doing that, and what data can go up and what data can go down between these different levels? Does the principal or the rector of a school need to know the activity level data of the students in the school? That's a question. Another way to think about it, and also this was mentioned, about these adaptive systems. So we need to have this data available for doing predictive algorithms, for adaption algorithms, for intervention algorithms inside of an individual tool. So this is Bienkowski et al.'s representation of intelligent architecture. And lastly, we can also think about learning analytics from an architectural perspective. So this is from JISC, who is responsible for, they're beyond many things, digitalization in higher education in England, but this is a learning analytics open architecture where you collect data in the bottom from students. It could be from a virtual environment like a learning management system, things they're doing at the library, etc., attendance data. You somehow in the middle have to store it and analyze it. So here they're suggesting a learning data hub of some sort, and then you have to process the data and you give it back to in actionable ways to students, to teachers, to heads of the school, depending on what you're looking for. You're looking for dropouts in universities, that's very popular, which students are about to stop studying at the university, or for an individual student, maybe some reflection over how they're doing. When we look at traditional educational research, you'll see that these are the kinds of data you'll see people using. They use academic information or things that teachers produce, for example, assessments or rubrics you use for evaluating students. You use the student-produced data, like maybe an essay they've written or their homework assignments. We have assessment and teaching, like the exams or quizzes they write on. Demographic data, like age and gender. Behavioral data, are they attending class, etc. So that's traditional data that you will use in education. And if you look in any educational journal, you'll see people using this data. What learning analytics brings to us, there's new kinds of data. For example, the activity data or the clickstream data, we call it, that you leave behind when you use a technical tool. Audio, video, facial expressions, eye tracking, where are people looking on the screen, what are they focusing on? Biosensors, they use a lot of skin conductivity. Are you sweating, are you, etc. We saw the examples in China of using the EEG. We can say a lot about that. Air quality, I know a project where they're looking at air quality, so students get less attentive after lunch when the quality in the classroom goes down, the air quality. fMRI data from neuroscience, they're trying to bring all of these things together. Now some of it might just be for research and trying to understand learning better, and others, like in China, might be in the classroom. So there's a wide spread of the kinds of data. But this data is usually interested not in outcomes of learning, but processes of learning, like understanding how learning is happening over time. And there's a whole subfield called multimodal learning analytics about how do you actually interpret this data. And I was just saying to Daniel before that you need to have a large team of people to deal with this kind of data, because a computer scientist cannot interpret the data from an EEG, I'll tell you that. And you need to have a psychologist or a med person to understand it, and then how does that actually apply for education? You need somebody who's got a good understanding of the field of education to see how these things all mesh together, which is why the government, when we had our center, wants people from these different disciplines to work together. When we look at the role of learning analytics, we can think of who are the stakeholders, who are the learning analytics for? Well, they can be for students and teachers or instructors, for institutions or the leadership, for policymakers, and also for researchers. So I think a lot of this work that's going on is for researchers as well. We always have to remember them. The actions that can be taken are reflective, or adaptive, or predictive. So predict, as I mentioned, predict who's going to drop out, for instance, or who maybe understands a concept and who doesn't. And the uses, we look for patterns to give us insight into trends or give us some kind of informed feedback. Learning strategies and learning trajectories, how are students, the strategies they're using for learning, etc. Predict trends like dropouts or successful students. Identify early failure, who's falling so far behind that maybe we should jump in and help them. Or give recommendations like we do in adaptive learning, or learning and teaching actions, or pedagogical resources. So there's a lot of these open educational resources. There's work around how do you recommend a good resource for somebody. And then Neil Schlater from England, he was at a conference we had in October, and he's talking, we should be calling this educational analytics, not so much learning analytics, because it's much broader. So because there's a lot of work going on in curriculums, on welfare, intelligent campuses, employability, and sort of institutional analytics as well, in addition to the low-level learning analytics trying to help individual students and teachers. Okay, so that's sort of, I'm not going to give a lot of examples because it could go on forever, but I thought because it's a lot of teachers, we could talk about some of the projects that we're having. So I'm going to give you 2 examples of different kinds of research that we're doing in learning related to learning analytics around adaptive learning, and one on something we're talking about, teacher inquiry, and how teachers can use student data themselves. 1 project's finished and 2 are underway, so I don't have results for all of them. So in Norway, we have had ICT skills as one of the skills beside reading, math, and arithmetic for over 20 years now. So it's always very integrated into the curriculum. As you know, in Scandinavia, we're very ahead in having technology and taking it into use really quickly in schools. The majority, all high schools kids will have a computer. Most secondary kids will have a laptop or a tablet, and even in elementary school or primary school, there's still good coverage there as well. Our national tests have been digital for a number of years, so all schools have actually quite good access. So there's one tool that we found that actually uses learning analytics that's in use, widespread use in schools, and only one. And it's a tool for adaptive learning and mathematics. So we have 2 reports, one placing this type of tool in the landscape of what it means to learn mathematics, because it is a very particular aspect of mathematics learning, and one that's been an empirical study of the use of it. This tool is called multi-smart øving. Øving means to practice, so multiple smart practicing. And it's developed by a publisher in Norway called Gyldendal, and it's powered on top of a recommender algorithm engine called Newton. And we'll come back to that in a moment. Because actually, maybe I'll say now, I was really curious as to how adaptive this particular tool is when it's built on top of Newton, which really uses machine learning and recommender algorithms, just like Amazon. When you buy this book, you might want to buy, or others like you bought this book. So they recommend that way. And this is very different than an AI system that uses rule-based, where it tries to make an understanding of what you know and what you don't know. So it's a different underlying architecture to how these things are done. This particular program is used by over 180,000 students, and almost 10,000 teachers have access to the program, which is more than 40% of all the student population in Norway. In this particular case, it's grades 1 to 7. On average, the students used 30 minutes a week for homework and 30 minutes a week at school. And on average, students perform 200 tasks per week. Now, this particular program is a replacement to what they called the workbook. So you would have your math textbook, and then you would have your workbook where you would be doing by hand all the assignments. So they say straight out it's replacing that. So when you see that students are doing 200 tasks a week already, we're seeing the amount of mathematical problem solving they're doing is much higher than it was when it was on paper alone. 66% of the teachers claim that multi-smart øving is an important part of their teaching in mathematics. So that's fairly high, so of the teachers that are using this particular tool. So the tool gives the teacher an overview of the competency of each student in the class. It adapts itself. It can give feedback to the student, but only on whether the question's right or wrong, and that's quite key. Some of the other intelligence systems try to identify misconceptions you might have, or to understand why you're making the mistakes you're making. This program doesn't do that. It's straight right or wrong. And it gives the teacher more time to go around and help students, of course. This is an example of one particular task they have to do. On the left, we have the time that you've used in the system this week, and on the right, you have a star that tells you the number of correct answers you have for this particular unit. And you start with a blob and you develop into a star and into a diamond based on the number of correct answers that you give. So remember that, correct answers, because this is important in the end. Here's just another example of another, you can drag and drop before you just wrote in the answer of it. This is a quick picture of the dashboard the teachers get. So for each student, they can get a class. This is a particular student. We've blanked out the names. How much time they've used in this particular chapter in the textbook, and how much how much they have achieved, good or bad. From 1 is a bit problematic to 5, which is great. Okay, so you get this kind of dashboard information about each student. You can look at an individual student, see what tasks they've been doing, etc. This is a class overview. And you can also go into each task and look at how many students are answering that particular. So you can actually identify difficult tasks that are being used. Okay, so the adaptivity that's used in the system, no one knows how the algorithm works. It comes from Newton, as you remember. But we know that the publisher has made a network of nodes and that a recommender algorithm's used. That's all we know. So of course it's using AI, it's using machine learning, and it's using a recommender algorithm. You have a number of students, you get the student data, you analyze the data, and you make a recommendation. So each individual student is made a recommendation based on all the other students that have used this program. So anyone like you who answered this way, you would be recommended a new task to do. Okay, so when we studied this system, we interviewed 8 teachers and 3 representatives from the publisher. We did 1 focus group of 4 teachers and 1 group of 2 teachers. We did 11 hours of class observation at 6 different schools. We did a survey and got over 1,000 teachers answering, and I will tell you that's a very high number. My postdoc, he was really, really excited to have so many teachers answer. And we did a critical discourse analysis, 13 videos and 4 text documents from the publisher who's advertising this tool, because it's nice to think about how they're promoting their particular tool. I'm not going to give a lot of results. It's pretty spread around the class from first grade all the way to 7th grade. You can see the large pie charts. The smaller ones are special education, and 3 classes that work with immigrants to Norway, and so people who don't have Norwegian as a first language. So some of the positive findings was that 88% of the teachers thought that the quality of the tasks was good. 82% felt that the tool was adapting well to the student's competency. Most teachers, 94%, thought that it was useful for giving students volume training. So if you remember 200 tasks a week, that's good. And there is an overview. They feel they had a fairly decent overview of the competence of their class and of individual students on the various topics. So that's good. But there are a few things that don't work. So one problem that we found as researchers looking at it is what we call the scaffolding problem. So if you know Vygotsky's idea of the zone of proximal development, you have what the student can do by themselves, what the student can do with guidance, and then what the student cannot do. And we really like to keep in this zone of development what they can do with a little bit of help. Now this particular tool doesn't really work. It should work to give you questions that are just beyond what you can do. But the problem with this system is that you're allowed 3 answers. If you have the answer wrong 3 times, you get a new question, and it takes you down in what it's considered difficulty level. The problem is if the teacher helps you or your parents help you when you're at home and you answer correctly, when you really can't do it, then the system's going to get into a habit of giving you questions that you can't do because you're getting help to solve the questions. So they try to tell the parents and the teacher not to help them on the first answer. Let them answer first, and then you can help them on questions 2 and 3. So there's a little bit of a problem with the algorithm there. We have some examples when Kjetil was in the schools. There was a boy in 7th grade who kept answering wrong, and it took him all the way down from doing an algebra question to counting the number of bananas on the screen. And so he was hiding in the corner with his computer so his classmates didn't see he had to answer these bananas. And when he answered that correctly, instead of taking him back up in progressively more difficult, it hopped back up to the question he couldn't answer. So he got in this loop of going from, so there's a little bit of problem with the algorithm, but this was not every student. The publisher would have to call to New York to get them to reset somehow that particular student to have the algorithm work again. The other problem, which is a problem with not just this tool, but many math tools, is the calculation problem. We give them things to solve that they really need to do by hand because they're just supposed to put in a single answer. So this was one thing which was actually, I thought was quite nice to see, is they've got either white breadths or paper that they're calculating on the side. The thing is the teacher loses that information, right, because they don't see how they're doing the calculations. And then the last one is this star problem, if you remember that. As Daniel will say also, that kids learn to game whatever system you give them. So if the goal of the student is really motivated by getting to that diamond, they're going to keep answering wrong so that they get easier questions. And we know students that do that. Yeah. So some of our concerns, we do think, we're not recommending not use it. In fact, it's actually really good. We really like it. Students, however, learn that mathematics is about right or wrong tasks, not about understanding creation or creativity. So you have to remember the placement of these kinds of tools. What is it for? It is good for what it's good for, but it should not be everything that math is about. Social activities and practical investigations are really important for developing students' understanding. So how are you using this in the classroom? And you have to have some kind of social activities even around mathematics. Students don't learn anything new in the system because it really, based on a recommender algorithm, cannot explain to you what you've done wrong. It doesn't have any understanding of why you've done anything wrong. As you mentioned with AI, it doesn't have that comprehension. There are other ways to build tutoring systems that have comprehension, but this one doesn't have it. And another problem is that in Norway, we don't get access to the student data. And in fact, we're really questioning about this because it's not allowed to send our data out of Europe, but the data is sitting in New York. And this loop problem with it. But all in all, we're quite happy with it. So, okay, so that's one project. Unfortunately, right now, the report is in Norwegian. We're writing a paper in English about it. Yeah. Okay, a second project is called Activity Data for Assessment and Adaptivity. And this is a project that is run by the Department of Education in Oslo Municipality. And it is funded by COES, which is the organization for municipalities in Norway. So even though the first 2 years of the project were run in Oslo, we now have a second 2-year funding, which will bring in more municipalities in the project. The project was motivated by the municipality of Oslo's desire to not have one vendor dominate in the schools. They don't want this. They want multiple vendors. And so this project brought in a number of schools and a number of vendors to work together because they had this idea that because the students are using many different tools, there's data out there among all these tools. So the students might be redoing things in the different tools and the teachers can't possibly keep up with that. Yeah. So what they do is you have not only multiple tools, but you have multiple dashboards. So how are you as a teacher going to keep track of your student around all of these different dashboards? So the idea then is to have a central dashboard that can give us some kind of information about it. I hop over that. Okay, so here's an architecture in the first project that was built that is built to standards around data exchange, etc., where you have a student who works on one particular vendor's tool up at the top. It goes through some national gateways and through a hub that we have built here that it says that any vendor that has data on this particular student who's on now, on this particular topic, share that data with this vendor at the top. So you as a vendor have the opportunity to make your tool more adaptive because you can get more information on that individual student. In the second part of the project, though, we've gone away from this idea, which was the beginning idea, and it works technically. That was the beginning. In the second one, it's going more to a central, and I'm putting in the brackets this dashboard thing because it's not really a dashboard. But we're going to be having something called an open student model that's going to be able to give the teacher an overview over all the tools and what we know about each competence from all the vendors for a particular student. So if someone's doing 2-digit subtraction with the denominator larger than the numerator, then we can get information from all the vendors about what tool that has been done. In this particular project, we interviewed municipalities, vendors, and teachers about their understanding of learning analytics, of adaptive learning, about learning goals, student competence, learning outcomes, assessment, etc. And there is no common agreement, or not agreement, but common understanding of these things at all, which makes these kinds of projects very difficult. So this was a very good project to go out and see what problems there are when you want to institutionalize or use these kinds of tools across the curriculum. Okay, so the last project I'll tell you about is teacher inquiry into student practice. This is based on an EU project we had many years ago where we were looking at teacher inquiry, which is the systematic, intentional, self-critical, planned investigation into one's own teaching practice. So it's about teacher professionalism, and in particular is looking at the data created by students in your classroom. So we are surrounded by data, and in Norway, the law on teacher education, or on not teacher education, but the law on schools is that teachers need to be able to analyze and reflect on their own practice, illuminated by new knowledge and experience. And part of that is this data that we get in this technology-rich classroom. So how can student data be a tool to support teachers in their professional development? So we want to help you look at this data. We can't expect you to be researchers, that's the first thing. So that in our old project, we had a number of focus groups with different teachers about how they were using student data, and they drew all these models. We analyzed them and came up with what we call the teacher inquiry into student data model, and it's where you have a kickoff question and you identify your assumptions. We come with a method. You either change teaching or assessment, and you look at the impact on learning outcomes, and you give feedback to students, and you share it again with employees. So it's like a 7-step method. Here's just a quick, I know you probably can't read it, but I share the slides so you can read it after. Different projects in one particular school that we were looking in. How can ASCII-RASI help non-functional students to increase their reading speed? So something like that. Can taking into use an educational technology tool improve reading speed for these students? So what data do we need to do that? How do we help to collect it? How do we analyze it? And then how can they do it? So they have all these different kinds of questions in these projects they carried out. So one of the big issues, as I mentioned before, is what data? What data do we need to answer the questions that we have? Because we don't always have the data that we need. And how do we collect it? So in one of our projects, we're developing tools for classroom teachers to use to collect data. And how do we analyze it, and how do we visualize it, and what do we visualize? Okay, because it's always a hard question. And this brings around this idea of data literacy. Because we ask teachers to be ICT literate, and I think we now ask you also to be data literate. How do you use this data, and how do you interpret and make it actionable? It's about all these different kinds of visualizations you can do. How do you understand them? And we know that the simpler, the better. And I know a researcher in the States who worked for 1 year to get the 2 correct questions that he was asking the class in order to get something that allowed him to change teaching practice. So it's sometimes these are too complex. Okay, in just 1 minute, what we have learned. It has to do with access to data, and I haven't talked about all the privacy issues, but we, as a national center, we're very, very conscious of all the rules and ethics regulations, etc. It's about scalability. A lot of things that you see, this is a research field, they're at the very small scale, short time. If we're going to scale it up, we have problems of interoperability. Another problem I haven't mentioned, and I guess you didn't mention either, about algorithmic transfer, because an algorithm made in one context can't necessarily be reused somewhere else because it's very context-oriented. Impact. Is the visualizations that we give them, are they usable? Do they understand what they mean? But are they used? So we can make all these nice tools, but are they actually used? Do they fit into the busy day of a teacher, for instance? And what are the learning outcomes? Does it really impact learning, all this effort that goes into this? And of course, we do think about fairness, accountability, transparency, and ethics. And I do think it is important because there are many different levels to this idea. We've got explainable AI, because in this problem I told you in the first tool, it doesn't know why you didn't do correctly on your math question. We really need to know that. As a teacher, you need to know what are they doing wrong. So we need to have algorithms that can explain themselves. We have machine ethics that has to do with, does putting bias? There are algorithms that have bias. How can we make sure they're not there? And responsible AI. Do we want these kinds of data collected? Do we want these headbands on our kids? That what he didn't tell you was they report every 10 minutes whether you're on task or not, and they post it to it's like a WhatsApp group, although it's not WhatsApp, it's the Chinese WhatsApp, to the whole parent group in the class. So every kid in the class, every parent that has a kid in that class sees every child in that class as whether they're on task or not. Do we want these kinds of things? And we need to ask these questions and be responsible about it. And finally, I just like to always end by saying we have to think about data as being reductionist. Do we reduce people? We're humans. The children are humans. We don't reduce them to their data and just their data. So I think there are places for these tools. We need to think about their use and remember that we only see a very little part of what's going on, and we don't see what's all around through their data. Okay.